Hey everyone, welcome to this explainer. Today we are unpacking a really critical, urgent shift happening in enterprise architecture right now. You see, AI models have hit a massive ceiling inside large organizations. Sure, they can write a brilliant poem or summarize a PDF in literally seconds. But can they navigate your company's messy incident reports, conflicting policies, and technical dependencies without completely hallucinating? Let's find out why the answer, and honestly, why it matters so much right now, relies entirely on structure. Here is our roadmap for today. We're going to quickly cover the enterprise AI problem, trace 4 years of evolution, enter graph engineering, break down the 5-layer architecture, and finally discuss why graph matters now. We're going to see exactly why this architectural shift is something companies simply cannot afford to wait on. Let's dive right in. Kicking things off with Section 1, the enterprise AI problem. So, to understand the solution, we first need to look at why enterprise AI is hitting a brick wall with complex organizational reality right now. We know large language models can generate useful text. That's a solved problem. The real challenge is making them operate reliably inside a real, messy organization. The enterprise AI problem is fundamentally a structure problem. Think about it. Your enterprise knowledge isn't neatly packed into one perfect document. It's completely scattered. It's like trying to piece together a company's history from a chaotic Slack thread, a random incident report, and a meeting record from 2 years ago. A policy exception might depend on an employee's exact role, a specific customer contract, and the specific date when each record was actually valid. You just can't feed that raw chaos into an AI and expect a perfect answer. The problem isn't the AI's intelligence. The problem is the structure of the data it's trying to read. Moving to Section 2, 4 years of evolution. It is actually fascinating how fast AI engineering has shifted to solve these massive enterprise bottlenecks. In just a few short years, we've seen a complete architectural progression, mostly because the industry realized that waiting around just isn't an option. Let's trace this rapid timeline. Back in 2023, it was all about prompt engineering, right? Crafting that perfect instruction for a model. But a perfectly written prompt cannot magically produce facts that are just missing from the model's context. So by 2025, we shifted to context engineering, managing RAG, or retrieval augmented generation. We started feeding models our documents. But here's the catch. Supplying more text is absolutely not the same as supplying better understanding. Then early 2026, we hit loop engineering, designing iterative agent cycles that observe, decide, act, and verify. But those loops had a critical flaw. They were way too linear. And that brings us to mid-2026 and the urgent rise of graph engineering, designing the explicit structures through which agents, data, and people actually work together. Just look at the difference here between sequential loops and concurrent graphs. If you have an AI agent doing a linear loop, it has to retrieve information, generate a response, run a security review, then run a logic review, and finally, a style review. Every single step waits for the previous one to finish. It introduces massive latency. A concurrent graph, on the other hand, makes the system structure explicit. It knows which tasks are independent, so it can dispatch the security review, the logic review, and the style review simultaneously. When work has no dependency, the system shouldn't force one. That parallel processing is exactly why a concurrent graph system can crush tasks up to 3 times faster. Okay, Section 3. Enter graph engineering. Let's move to the core concept and see how this actually changes the way AI accesses your organization's information, moving beyond mere similarity. A really simple mental model for this is comparing vector search versus graph traversal. Vector search relies on semantic similarity. It finds what merely looks related. It's kind of like searching for a recipe and getting an ad for a frying pan. That works if the answer uses the exact same language as your question. Graph traversal, however, is a whole different ballgame. It follows explicit paths to find what is actually connected, completely regardless of the words used. Let's look at a practical example. Imagine asking an AI agent, why did we drop Redis for the job queue? If you use traditional vector search, the system might just pull up random documents mentioning the keyword Redis, or job queues, or other adjacent technical terms. It gives you documents that share similar language, which completely blinds you to the actual historical sequence of events that led to the decision. It is incredibly frustrating when you just need the real story. By contrast, a graph system traverses a connected path. First, it starts at the job queue. Then, it follows a link to a decision record. Third, it traces that back to a specific incident, identifies the root cause, and finally lands on the replacement technology. This traversal reconstructs the entire decision for you. It gives you an evidence-backed chain of relationships. This proves the central thesis of why we need this right now. In complex organizations, structure is not just a way to organize knowledge. Structure literally is part of the knowledge itself. And this brings us to the Enterprise Knowledge Graph, or EKG. It's a structured representation of an organization's entities, so your people, systems, policies, and the explicit relationships between them. It knows that an incident caused a service disruption or that a decision record supersedes an earlier one. This EKG serves as a structured memory for your AI systems. It's a real light bulb moment when you realize agents can trace actual causality and dependencies. No more guessing based on word similarities. All right, on to section 4, the 5-layer architecture. So how do we actually build this thing in production? Let's break down the practical how-to required to make graph-based AI operational right now. Layer 1 is data capture and quality assurance. This involves change data capture, temporal fidelity, and strict quality controls. That second point, temporal fidelity, is huge. Think of it like a time machine for your data. A graph shouldn't just represent what is true right now. It absolutely must preserve when information was created, changed, or retired, because knowing when a record was valid is just as important as the record itself. If poor quality, temporally inaccurate data enters the graph, your downstream AI just inherits all that uncertainty. Next is Layer 2, ontology development. This defines the semantic structure of the graph. Without defining clear relationship types, things like supersedes, caused by, or depends on, a graph is really just a bunch of meaningless links. An edge between two nodes could mean ownership, or timing, or just pure coincidence. You have to make those relationship verbs explicit. The ontology layer is where you actually define your institution's specific meaning. Moving to Layer 3, graph construction and entity resolution. The source material notes that entity resolution accuracy commonly sits somewhere between 73 to 94%. Think about that for a second. If your system sees Dr. John Smith, J. Smith, and John Smith, MD, it has to figure out if that is the exact same person or just 3 different people who happen to share the most common name on Earth. Incorrectly merging entities creates false relationships, while failing to merge them conceals genuine ones. That 73 to 94% range means entity resolution is a massive quality risk that you must actively manage. Now for the real payoff. Layer 4, AI enhancement with Graph REG. This delivers context-aware, traceable responses that are grounded in explicit relationships. This is where the magic happens and why companies are rushing to build this now. Instead of just grabbing document, an agent can trace a highly structured evidence path. It jumps from a customer account to a specific contract to an applicable policy and finally over to an approved policy exception. The results of this are absolutely staggering. Grounding language models in these explicit graph structures can lead to up to 85% fewer hallucinations. 85%! Explicit structure gives the language model far less room to just invent unsupported connections. It is forced to stick to the explicit paths you've engineered. Finally, Layer 5 is application integration. This includes role-based dashboards, natural language query interfaces, and workflow applications. Basically, it delivers graph-powered intelligence to the right people with the right permissions. An executive gets a concise risk summary, while an engineer gets a complete technical chain of incidents. This layer turns the EKG from a back-end technical asset into a daily operational tool that actually drives business decisions. Let's wrap up with Section 5, why graph matters now. We need to zoom out to the broader strategic picture and answer the biggest question of all. Why does all this graph engineering matter right now for your enterprise? Well, it comes down to governance, auditability, and human checkpoints. It matters right now because enterprise AI cannot be evaluated only on fluency. It demands trust. Graph engineering makes the entire workflow inspectable and controls data access. But most importantly, it preserves human authority by allowing you to build intentional human checkpoints. Human review isn't a failure of automation, folks. In high-stakes decisions, it is a deliberate, completely necessary node in your system graph to maintain control. This quote from the source material hits the nail on the head. The next generation of AI platforms will not be defined solely by what an agent can generate. They will be defined by what an agent can understand, connect, verify, and explain. The strategic advantage in enterprise AI is no longer just using bigger models or writing clever little prompts. It is building the architecture, the ontology, and the topology that makes the AI's answers meaningful, verifiable, and traceable in the real world. So, as you think about the messy, disconnected, yet highly vital data floating around in your own organization, I want you to ask yourself this final question. Is your AI just generating impressive sounding answers based on semantic similarity, or does it actually understand the DNA of your organization? The era of just searching text is ending. The era of engineering true understanding is here. Thanks so much for joining me for this explainer, and we will see you next time.
Found this useful, don't forget to hit the like button. It really helps the channel. Subscribe so you don't miss future videos, and share this video with someone who needs to see this. It helps grow the audience and lets us create more content like this for you.